who's the Asset Management Program Manager at Ferrovial. So there he is. Come on up.
Thank you.
Go down here real quick. Just want to see the
Here?
Yep, right there. Yep. Headphones. Yep.
Oculus? No, I don't think so. Oculus? Yes. I don't. Hello. Good morning, everybody. How are we? I am David López. I am a program manager at the innovation direction of Ferrovial Holding. And before starting with the session, I would like to know something about you. I would like to know how many XR producers and how many XR supplier and consumer we have in this room. So please, I'm gonna ask you to raise your hand for those who are XR producer. Okay, well, I'm gonna assume that the rest of us are XR consumer and we are in Ferrovial. And the reason why I am making this question is because in this presentation, we are gonna start showing how we started our journey about XR, that it was in 2020. Then we are gonna show where we are today, 5 years later. But we are gonna go also through the challenges that we have faced during this path. And please, whether if you are XR consumer or XR producer, if you think that these challenges are no longer part of this ecosystem, stop me later and let's discuss about them. So before starting the presentation, what is Ferrovial? To know in what kind of industry we are working on. Ferrovial is a multinational company dedicated to design, build, operate, and finance infrastructure for mobility. We do airports, we do highways, we have also a division for energy, we have also recently launched our data center division, and we have more than 20,000 employees spread around the globe. We have presence in the UK, in Canada, in Australia, US, India, etc., etc. So now that we know in what type of industry we are working on, that is in the construction industry and in the operation industry of infrastructure, let's start with the presentation. How we started? Well, it was in 2020, during the COVID pandemic. I think that, as many other companies, what we wanted to make was the meeting more immersive. So we have the brilliant idea of why don't we scan one person and we put that person in a virtual meeting room? Why don't we do this with several people and we will have an amazing virtual room? Let's try it. Well, what do you think it happened? It was in 2020. Microsoft just released the Azure Kinect camera, this amazing camera that allows you to get the point cloud of the environment. What do you think it happened? Have you ever tried to transmit millions and millions of points over the internet? Well, it is a bit embarrassing. I'm gonna show it to you, but basically, we just were able to show a small portion of one person, of the body of one person, moving the hand. So, what happened? Well, we totally failed. We clearly failed. What did we do? Well, I think that, as many others that we are here today, we learn from the process. We learn from the process. And that is what it has brought us where we are today, here, 5 years later. That thing that you see in the right corner is one of our XR lab. That one specifically is in our Austin offices, where we have 3 differentiated spaces. We have the driving simulator, we have an immersive cube, and we have also a space reserved for XR technology. Here is where we bring our people, we bring our stakeholders, and also members for the public to explore different use cases related to XR technology. And we have 4 of these. This is the one in Austin, but we have another one, a twin of this one in the UK, another one in Australia, and another one in Spain. In these XR rooms, we have tested more than 25 devices. You can see the table here of the different devices that we have been testing, and also against what use cases. And we have had more than 725 users along these 5 years. And to move forward with the presentation, let's use that example that we have there, that we can see a user driving a virtual highway. Let's use that one. What do we need in order to create that kind of solution? Well, the first thing that we need is to create the 3D environment, right? Here, for the time constraint that we have, we are going to just focus on what we know in this industry as brownfield projects. But greenfield projects that are existing, that are infrastructure to be built, new infrastructure, is also very interesting for the underlying data strategy that it has. But for the time that we have, let's focus on existing infrastructure. How do we design those kind of models? First, the first thing that we do is we try to collect all the different data sources that we have available. We take photogrammetry, we take satellite images, we take point cloud, as-built, everything that we can to build that 3D model. Then, with the latest point cloud that we have available, what we do is that comparison of the 3D model against that point cloud. We can see here, for example, in the video, that we see one toll rate sign that is going to appear now that is not in the correct position. So we make those small adjustments when are needed. And finally, this is the kind of result that we have. Does anyone in the room recognize that highway? We are not local, no? That is the North Taran Express, a highway that is connecting Dallas with Fort Worth region. That is one of the highways that Ferrovial operates. And here, in the creation of 3D model, I would like to raise 2 challenges that we are facing. The first one is related to the pace at which we are creating 3D models. If we want to create a 3D model of a 50 miles highway, it is not a matter of days, probably a matter of weeks, even months. We have made a huge improvement in the last year in this sense. We are now much faster, but we want to be even faster in the creation of 3D models. And the second challenge that I would like to highlight, and we have not figured out yet how to solve it, is regarding underground assets. Even if we have the as-built of the infrastructure, that it says the fiber conduit should go here, and there this pipe should go here. The reality is that that doesn't match reality. So for brownfield asset, that is still a challenge that we have present. Okay, now that we have the 3D model built, let's use them. I challenge you to model this controller, for example, and in high detail definition, and you put it in a virtual reality application, and I promise you, you're going to be able to do whatever you want with this controller. Now, I challenge you to do the same with a 50-mile highway with 3,000 vehicles being simulated in real time, and with about 300 sensors or virtual sensors generating synthetic data. What happened? Does anyone have tried that? Well, that is the kind of industry we are. So here, the kind of thing we are doing. First, we are balancing very, very, very well. We are taking care of what are the business requirements and what are the level of detail that our model needs. If we have this use case, why do we need to prepare the model in that high definition level if it is not required? And secondly, we are also following the strategy of divide and conquer. What we are applying are dynamic loading techniques, between others, that what allow us is to load only the part of the environment that is interested for the user. If we know that the user is moving toward this direction, we load that part and unload that other part. And we do the same for traffic. We only represent the vehicles that are close to the surrounding area of the user. You can see here in the second video, for example, that we have a yellow vehicle there in the mirror. But this is the origin of another challenge. What happened with those virtual sensors that you have 3 miles away? Because traffic is not being simulated there. So you are not generating synthetic data of those sensors. What happened? Yeah? So here is when we started using and separating the 3D engine from 2D simulation tools. So what we are doing is using the engines, Unity, Unreal, whatever, to simulate the thing, to represent the thing that is for what the engine has been created for. And then using 2D simulation tools, for example, what we can see here on this side is a traffic simulation tool that is called Sumo, to do the rest, to simulate and generate the data. And connecting both the 2D simulation tool and the 3D in real time. It's still a challenge. I promise you it's still a challenge when you manage a lot of miles. Here in the second video, what we can see, for example, it does traffic simulation tool with the engine, and what we are trying to do is to optimize the position of antenna for V2X communication. And here in this other video, in the last one, the right side of the screen, what we can see is, this is any logic, this is another simulation tool, and what we are simulating are the operations that happen in vertiports. Vertiport is a new business that is starting right now, and what we are doing here is testing different design options, understanding what is the amount of staff that we need, where are the bottlenecks, how we can increase the capacity of the infrastructure, where should we position the sensor, et cetera, et cetera. Okay, and coming back to our first example, the use cases that we use, that were related to behavioral analysis, that user that we saw that was driving a virtual highway. In this kind of project, behavioral analysis projects, what we are trying to understand is how the user behaves in a specific way under specific circumstances in a virtual environment and trying to translate that to the real world to make better decisions at the end. And this is how we started. This image is from one of our experiments from 2022, I think it was. Basically, what we did was recruit more than 350 people from the public that were fulfilling a specific criteria that we wanted to get insight from them, to know, to understand how they were using our highways. And we see that we are using, in this time it was called Oculus, that will be the first meta. What do you think that was the feedback that we received from the users? It is heavy, it is uncomfortable, and on top of that, it messes up my hair. So I don't like it. Then we have this gaming steering wheel. This is the G29 Logitech. It's an amazing steering wheel, gaming steering wheel. However, we were using, you can see the hand of the participant. We were using the paddle shifter as turning indicators. So it was not realistic at all. And then we have here another thing, and that is not coincident. That is a trash can. Why? Because with this setup, we were, during the calibration phase of this experiment, getting around 70% of the participants with motion sickness. This kind of project, they have a calibration phase and then the experiment itself. It's true that during the experiment itself, once all the variables of the experiment are calibrated, the motion sickness was reduced to 10%. But still, 10% of the participants that we were paying, we were not getting data from, and on top of that, we were producing motion sickness to them. What did we do? Well, we changed the VR headset for 3 screens, giving a wider vision to the user, and then we changed the seat and the gaming steering wheel for a full motion simulation platform. The result, from 17 or from 10% to 0% of motion sickness. So here are some of the lessons learned of this use case that we have used as a sample. And we have experienced similar things with other use cases. For example, remote assistant. We have been trying to help our technicians and our operators that are out there in the highways, in the airport, whenever. We have been trying different AR devices, a lot of them. And we see still some challenges regarding durability when it is raining, when we have a lot of dust in the environment, regarding also how do we enroll those devices with the IT, security, compliance protocol, et cetera, et cetera. And here on the left side of the screen, we have something I like a lot. We used to have a pen. The pen was designed just for one thing, to write, easy. Then we have a mouse. We can use a mouse for multiple things, but it still has 3 buttons, right click, left click, and the wheel. And then we come up with this kind of remote with a lot of buttons, joystick, movement, et cetera, et cetera. I still remember the first time I gave the Oculus to my father, and it was like, his reaction was like, wow, David, this is amazing, this is great, but I am totally lost. I am totally lost. And that is what usually happens, and it also happens within our businesses. And it's happening a lot with senior management. And something that we are doing lately that is helping a lot with this is we don't release a virtual reality application without including like a mini tutorial before the application itself. It helps a lot the user to get familiarized with the controllers, with the button, with the function, et cetera, et cetera. And that image that we have in that corner is an image that I took 2-3 days ago that is in one of our XR lab, and those are the kind of devices we are lately testing and exploring. We have the X-Real, Viture, I think those are the HoloLens, Meta, the Vision Pro, and the Oculus Pro 2. Well, before finishing, I also would like to share some other use cases more related to digital twin, but that also prove how we are getting value from this journey, not only from SR. Here on the right side of the screen, we have what we call the operational digital twin. And what we are doing here is designing how we think the vision that we have regarding an asset management tool, in this case for a highway. And what we have done is connecting a digital twin, easy-to-use interface with an asset management tool. So we have all the correspondence of the 3D model with that asset management tool. We can see there the GIS representation of that high mass that we have placed in the virtual environment. And in the other side, we can start, for example, with operation simulation. Here what we have is how we simulate a lane closure, how we design that where the cones need to be, how we simulate the traffic based on historical traffic demand, and how we analyze the impact that plane closure will have in the future, and also how can we monitorize that operation. Then we have the one on the top regarding behavioral studies. The one specifically, it was still done in VR. It is related about how to influence the driver positively in order to take the managed lane when the user is in the general purpose lane. Then we have another one related to design validation. Thing that we are doing here is, for example, analyze the visibility of the curves, see if the luminaries are correctly placed in the correct location, the same with signaling. And then to finalize, we have also done some crowd studies in airports, where what we trying to understand was how the different type of passenger behaves and how evacuation works, what would happen in case of evacuation. So to close this session, I like a lot the first point, because I think it defines very, very well what happened to us with the first behavioral analysis project that we were running of using the VR headset directly, when that was not really answering our business requirement. There was a much easier way to answer our business requirement, but we decided to go with everything from the very beginning. So we have learned a lot during the process. Another thing that I would like to highlight is the importance of these kinds of events. We have seen before the slide with some internal KPI about where we are today. In that slide appear a number that is 35 partnerships, meaning that, I mean, this journey, it is not something that we should do alone. If you can do it alone, you are going to arrive much later than others. Meaning the importance of having good partnership in your ecosystem. To finalize, also, we have proof, and we have delivered a lot of value to our business unit during these 5 years, meaning that there is plenty of value of the journey. However, the hardware may not be ready for all destinations, meaning that we have also experienced that for many, many use cases, specifically in the kind of industry that we are, that is the construction and the operation of infrastructure, there may be some limitation still with the augmented reality and virtual reality technology that we need to continue improving in that sense. So guys, thank you so much. I hope you like it. For me, it's a pleasure to share this insight from Ferrovial. And I think we have still 4 minutes. If you have any question, feel free to ask. Yeah?
I have a mic for you. Sorry.
My name is Sharon Han from Southern California, Edison. My question is, when you make those 3D asset and environment, especially that highway one, how did you handle that size? It must be huge.
It is huge. Must be, no, it is huge. As I said before, divide and conquer. What we are doing is, in terms of size, we don't build everything at once. What we go is section by section, and even depending on the use case, you have seen also the operational digital twin example. In that case, what we are doing is the underlying data strategy that we follow. We go object by object. That is huge work. However, it makes interoperable all the solution along all the life cycle of the asset. So how? Looking at this, business need. What do I need? Do I have a use case that requires high definition detail and object by object because I need to use that model for operational use cases? Yes, so we need to go through the long path. Now, I just need to make a quick idea of how my infrastructure is going to look like. Okay, let's use InfraWorks, let's use concept station, let's use other kind of tool that allow you to get the model in a low level of this detail. So it depends. It depends of what you need. But it is not easy. I mean, that is one of the main challenges of this industry is the size, the computational power that we need. We have suffered a lot with that. We have learned a lot with that. Any other question?
Hello? Hi. Question on the dynamic loading piece. I'm guessing that you have to have connectivity and for that to be functional, right?
You need.
Okay.
And that is a challenge also when you are building a standalone application. You need to have connectivity in order to be downloading and uploading the new part of the model. And more than that, the challenge is how long should be those sections. How soon I started loading the next session when the user crossed this line and unloading that other one. So there are a lot of metric that basically is more like a test, and let's see what happens. Test again, test again, test again, iterate until you get where you need to be.
So for use cases where your primary users are in an offline environment, the entire experience would have to be downloaded? Okay.
But here you have the limitations. If you want to work locally, you may have, and you can have 20 miles of those environments. You can drive over them. You can have traffic not simulating realistic traffic demand, because if not, you're not going to have power enough, not in a PC, in a local PC. So you have limitations if you want to run locally. We have some use cases that we have been working locally too.
Thank you.
Very welcome. Okay, thank you so much. It's having a pleasure.